Hello, I'm Dan Pfeiffer, and today I will be showing you one of my favorite lab activities that we do all year. I think we do a really good job with this over at Glenbard South, and I'd like to share it with some of the science community out there. The program that I'll be using today is called XSplit, and one of the nice features about this is that I can change from one screen, full screen. I can even split it up so that I can have my video feed with the web feed also. And I've used a lot of technology in the classroom, as you'll see here, and it's been very beneficial, especially on sometimes when I've been ill. There haven't been really substitutes who are qualified to teach the AP Physics level, so I've used Skype also before, and the screen sharing feature on that, and it works really well for more of a lecture style. But whenever possible, I do prefer inquiry-based science. I want the students to discover science on their own, and the lesson today that we'll be talking about is all about electricity. So I'm going to switch over here and show you the feed. Now, this is my home page right here, and we will be going to the ISP, that's Introduction to Scientific Principles. It's a physical science course which covers everything from chemistry, plate tectonics, earth science. It just is really a overview course. And I like to post the learning objectives for each unit. Here, I'll just click on one to show you what that would look like. Alright, Unit 4 learning objectives. And then there you go. And I generally have these written as I can statements in which students can check off as we go through the unit. I'd like to see these reduced to just a few core concepts as I move forward in education. But back to what I originally wanted to show, which was the Waste Not, Want Not project. And that actually is in the Unit 5 handouts, which I found it very helpful to put all of the handouts online. I have a lot of students who are able to find their makeup work more easily, and it just really made my life easier and the students' lives easier as well. So before we got into the lab, I'm going to show you some of the precursory things that we did, discuss the lab, and then show some results, hopefully with some video of actual footage from the lab. So here we are on this page with Electricity Inquiry Day 1. I just put a bunch of materials on the table and just tell them light the bulb. And you know, you put things like tin foil or batteries or any kind of conductor, and maybe see if there are kids that can find creative ways. And it takes surprisingly longer than you would think for students to actually discover this on their own. But there are three things that are necessary, and obviously that's the power source, the load, which is the light bulb, and a complete circuit. And so we practiced with just playing with circuits and trying to get a feel for how it works. Alright, then we moved along, and there was a bit of reading, a little bit about Coulomb's law, and just generally what is current and how does it flow. Then after that we get to this project, the Waste Not, Want Not project. And the idea of it is we will be measuring power as our output, as our dependent variable. And that's a given. We tell them power is our dependent variable. I'm going to switch back over so that you can see me as I'm talking about this. There we go. Power is everyone's dependent variable, and then I have them just make a list of, well, what are some things that we can change. So we get this broad list of independent variables, and students will oftentimes say things like the number of batteries or the size of the wire, meaning diameter or length. You'll also see sometimes the kind of battery, A, C, D, 9 volts. And then what happens is each group is to test one variable. Then they present their findings to the class. This year I decided to do it with whiteboards where the students were to show a sketch of their graph. They were to also include what kind of relationship it was, because we talked a little bit about direct and inverse relationships. And then we talked about what would a general rule be. So, for example, more batteries will give more power output. And the way we measured this was with Vernier software. We used the solar collectors, and it would measure the voltage input and then calculate the power based on that, and it just gave the students a nice power output. So, continuing on. So as I was saying, step one is students independently find their own data, and then the forum, the shocking results forum, is where they present the waste not, want not. And part of this is to get them to see the idea of, okay, how much power do things use? How can we conserve power? What makes things use a lot of power? And really, the students do fairly well with this part of it. I think the thing that separates the higher level students and some of the more struggling students would be when it comes time to synthesize everything together, and they have to take those results from each group to come up with a design that will produce the greatest amount of power. And then we make it into a contest with some kind of prize, extra credit in this case, for the top 3 teams in each class. And they really do get into it. I found that there is some variance with types of batteries. So what I've done is this year I ordered a whole lot of snap circuit battery packs, power supplies, I guess I should say. And this will eliminate the variance and the unfairness of types of batteries. I do find that the students have some surprising results here. For example, A, C, and D batteries are all 1.5 volts, and they oftentimes will say, okay, well, this is a direct relationship, but when I ask them to look at their data a little more closely, you can probe them into the right direction. And they'll see that, okay, well, it's a variance of only maybe 0.05 watts or something like that, which really isn't that much, and I kind of bring it into perspective. Well, what if we took that graph and went back a little bit, zoomed out, and that works pretty well. Again, this is one of my favorite activities at Glenbard South, and I hope to see it spread throughout the science community. If you have questions, my email is danielapfeiffer@gmail.com, and I would love to hear from you for feedback or other ideas that we can add to this lesson. Thank you.